So, good morning, grade 12 STEM students. How's your morning? I hope everybody is okay. So, we are now in session 3 of your capstone, specifically mathematical induction. Today, we're going to discuss the methods of proof, and we're still on the how part of our discussion. But before we start, let's have the objectives of this session. So our first objective is to discuss the importance of mathematical proofs, MP in MI. Number two, demonstrate understanding of mathematical proof and its procedures in relation to mathematical induction stages. Number three, do hands-on and minds-on activities involving mathematical proofs. And number four, provide simple reflections, conjectures, and testing through mathematical proofs. So in our education, our curriculum guide has these twin goals, which is the critical thinking and problem solving. So we all know that in our mathematical investigation, it really involves critical thinking and problem solving. That's why it we are hitting two birds in one stone, which is critical thinking and problem solving. So what is really the definition of mathematical proof? A mathematical proof is considered to be the central to the discipline of mathematics. Proof is not a thing separable from mathematics. It appears to be in our curricular. It is essential component of doing communicating and recording mathematics. That is according to not 2002 and Soenfeld 1994. So those are the definition given by those two authors. So in our mathematical investigation, we are trying to prove if the formula we are trying to prove is true or false. In mathematics, a statement or a conjecture is an expression that is either true or false. Some examples of the statements are, so ito yung mga examples niya, 1 is equal to 0. Of course, we all know that it's not true, it is false. 3x is equal to 5 and y is equal to 1. These are statements, okay? Uh, they may be true or false, okay? These are just examples of statements, mathematical statements. X is not greater than 0. It may be true or false. Two different lines in a plane are either parallel or else they intersect in exactly one point. Next, the sum of two consecutive integers is equal to the difference of their squares. So these statements may be true or false, uh, depending on the value of the variable. Okay? So we are going to prove using these various methods. So these are the various methodological or methodology in proving. So we have the direct proof, the proof by contradiction, contrapositive proof, and proof by mathematical induction, which was given or can be seen in our pre-calculus curriculum, but we haven't discussed it kasi kulang tayo sa oras ng mga panahong yun. So we're going to discuss it now, and it is very easy. So just sit back, have your pencil and your paper, and you participate by solving our examples. Okay, so let's start with direct proof. Let's have this conjecture. So we're going to prove this conjecture. Let n, let n and m be integers. Okay, so they may be positive or negative or zero. Then if n and m are both even, take note of that, then n plus m is even. We have to prove it. Kung si n and m daw integers sila and they are both even, then their sum, n plus m, is also even. So we have to prove it. Now, let's move on to the proof. Using the direct proof, let n and n be integers, then n and m are both even, then n plus m is even. So this is now our proof. If n and m are even, so yun, if n and m are even, then there exist integers k and j such that we let n is equal to 2k. Okay? What we're doing here is we're going to assign the integers k and j. Integers din si k at si j. So, sabi dito, we let n equal to 2k and m equal to 2j. Okay, I hope you understand that. So, this is the beginning of the proof. Then, if n plus m will be equal to, anong katumbas ni n? 2k. Ayun, 2k. Did you see that? Next, m plus m, anong katumbas ni m? 2j. So, we're going to add that. 2k plus 2j. Do you still remember your lesson in grade 7 which is common monomial factor? This is a binomial, right? What is the common monomial factor? What is the common factor between, this is one term, this is another term. You look for the common factor. What is the common term in these two, what is the common monomial factor in this binomial? Anyone? Ano yung pay pareho nila? Very good, it's 2. Thank you very much. Okay, so we're going to factor out 2. So, ilalabas natin si 2. Ito siya. Nilabas natin siya. I hope you can see my circle, kulay red. And we're going to divide 2 to the both terms. 2k divided by 2 equals k. Ito yun, k. And then, 2j divided by 2 equals j. So, nilabas natin si 2. And this 2k plus 2j is also equivalent to 2 times the quantity k plus j. Pareho lang yan kasi pag dinistribute mo si 2, magiging 2k plus 2j din siya. Therefore, since meron tayo na-extract na 2 dito, si 2 ay even. Tama? It is the smallest even number. Even prime number, smallest even prime number. So, pagka minultiply mo sa 2 ang any number, it will become even number. Since j, k, and j are element of z, si z sa algebra, ang kanyang representation ay integers. Okay? Positive and negative numbers including 0. Ibig sabihin daw, since si k at j ay element ni integers, therefore, ang sum nila, k plus j, element din ni integers. Therefore, n plus m is even kasi ang ating sum merong 2. Okay? Lahat na i-multiply mo sa 2 ay even number. Okay? I hope you get that. So that is a direct proof, proving using direct proof. Okay? This is our conjecture, and we prove it that it is, or the sum of n and m is even. Okay? That is an example of a direct proof. Next, we're now going to discuss proof by contradiction. So we're going to prove that square root of 2 plus square root of 6 is less than square root of 15. So in this part, nakita na ng square root, medyo nahihirapan na yan. Hindi, madali lang yan. So using the proof of contradiction, we're going to contradict this statement. How? Okay, so in this part, bakit ayaw sumulat? We're going to contradict this statement. Square root of 2 plus square root of 6 is less than. Ano ang contradiction ni less than? Anong kabaligtaran niya? Diba? Greater than or equal? Tama? Yun yung nagko-contradict dun sa statement. So, imbes na square root of 2 plus square root of 6 is less than square root of 15, gagawin natin siyang square root of 2 plus square root of 6 is greater than or equal to square root of 15. Because we are using proof by contradiction. Okay? We are contradicting this statement. Okay? I hope you get that. This is the second proof, okay? Ipanibagong proof na to. Yung kanina, direct proof siya. Wala tayong ginawang contradiction, wala tayong iniba. Kumbaga, nag-assign lang tayo. In this part, i-contradict natin yung said conjecture. Okay? So, this is our statement contradicting to this one. Ito, to this one. So, square root of 2 plus square root of 6 is greater than or equal to square root of 15. So, this is our proof. Shortcut siya, pero naglagay ako ng solution. So, ang nangyari, tingnan nyo, shortcut na kagad, naging from this one, square root of 2 plus square root of 6 is greater than or equal to square root of 15, naging quantity 8 plus 2 square root of 12 is greater than or equal to 15. Paano nangyari yun, ma'am? And then, from this one, naging 2 square root of 12 is greater than or equal to 7. Saan nanggaling si 7? And then, naging 48, tapos, is greater than or equal to 49. So, let's have this in our detailed solution. So, our contradicting conjecture is, or statement is, square root of 2 plus square root of 6 is greater than or equal to square root of 15. In order for us to eliminate the square root or the radical sign in the right side, of course, we're going to contradict the operation. And what is the contradiction of square root or extracting the square root? It is squaring. Okay? So, iba ang extracting the square root sa squaring. Okay? So, we're going to square the both sides of our inequalities. Okay? So, we square it. Ito yon. So, we are squaring it. Ito yon. So, the square of the quantity square root of 2 plus square root of 6 is greater than or equal to the square root, the square of the square root of 15. Ayan, so naka-enclose siya ng parentheses. So, this one, the left side will be treated as a binomial. Okay? The left side will be treated as a binomial. So, we square the first term, which is square root of 2. Ito yon. The second term, the second term and the middle term will be multiplied to the first and the second. So, square root of 2 times square root of 6 times 2. This is the rule, okay? Rule to. Twice the product of the first and the second rule. Next, the third rule, ito yun. The third term, I mean. Ito. We just square the last term. Okay? And then, syempre, yung kabaligtaran ng square root ay square. Makakancel na yun. We will have 15. Wala na yung square root. Okay? I hope you get that. So, we're going to square the square root of 2. We get 2. And we're going to multiply 2 times 6. We get 2 square root of 12. So, we square the square root of 6. We have 6. And then we write 15. Next, we add 2 and 6. We will add 2 and 6. So, we have 8. Now, we just rewrite 2 square root of 12 is greater than or equal to 15. Next, we subtract 8 to the both sides. So, we got 2 square root of 2 is greater than or equal to 15 minus 8. I hope you get that. Tinanggal natin si 8 sa left side, dinala natin sa right side by subtracting both sides by 8 or by adding negative 8. Okay, pareho lang yan. So, performing the subtraction or the operation, we have square root of 2 square root of 12 is greater than or equal to 15 minus 8 is 7. Kaya siya naging 7 dito. Ayun. Kaya siya naging 7 na dito. Okay? So, ang dami niyang pinagdaanan. Tapos, dito, yun na kagad yung pinakita. Okay, next. In order for us to eliminate the radical sign, we have to square both sides. So squaring this, you can type this in your calculator, 2 square root of 12, and then square, we will have 48. And then the square of 7 is 49. Therefore, is 48 greater than or equal to 49? True or false? It's false, right? So, therefore, the last statement is clearly not true. Ito yon. Hindi siya true. Kasi nga, 48 is not greater than 49. It's less than. Therefore, we reach the contradiction. Therefore, we prove that square root of 2 plus square root of 6 is really less than square root of 15. I hope you understand the conclusion. 48, palitan natin yung kulay. 48, 48 is greater than or equal to 49. False, di ba? So, we go back to our original statement. Therefore, kung false yung ating last statement, ibig sabihin, tama yung original statement natin na square root of 2 plus square root of 6 is less than square root of 15 kasi hindi siya greater than. Okay? So, I hope you get that. That is proving by contradiction. Next, we now move on to proof by contrapositive. So, contrapositive, ibig sabihin, you are negating both sides. So, kunwari, if P is positive, then Q is positive. So, kung i-negate mo yung dalawang yun, if P will become negative, and Q will become also negative. Okay? I-negate mo sila. Negation. Okay? So, this is our hindi to na-discuss sa sa logic, sa GenMath kasi sobrang layo na niya. So, if you want to understand it further, you may have general mathematics. You may browse your book or I can send it to you, the soft copy of the book in general mathematics and in pre-calculus. So, nandun lahat. Etong mga to na inaaral natin ngayon, na nire-review natin, inaral na natin sila noong grade 11. Pero yung mga iba, hindi natin sila na-touch kasi sobrang layo na nila sa ating, nasa pinakahuling part sila. Okay? So, now, proving by contrapositive, ibig sabihin, you are negating both statement. So, let's have this statement. Let n be an element of z. Ano kasi si z? Integers, positive and negative, including 0. If n squared is odd number daw si n squared, then n is also odd. Pwede ba yon? Let's prove. So, let's have the proof. By proving by contrapositive, we have this proof. Let n be even. Ano kasi si n? Sabi add, di ba? Dito, anong ginawa natin? We let n be even number. Nanggugulo yung mga pusa ko. Okay, so if n is even, then we let n is equal to 2k. Tandaan nyo, hindi mo nawawala si k dito kasi we are proving. So, we use k, j, z, n. So, yun yung mga palaging ginagamit natin. So, kung si n, kung yung kaninang by direct proof, paano na nalalaman kung even si number? So, syempre, merong 2 sa una. Okay, we multiply the number by 2. So, ma'am, bakit po ganyan? Bakit may 2k na naman? Kasi nga, ninegate natin yung statement na si n squared daw ay odd. By contrapositive, we let n be even. And para maging even si n, we let it equal to 2k. Kapag multiply mo ang number sa 2, it will become even. And k is an element of z. which is an integer also. Then, we equate it to our n square. N square is equal to the square of 2k. Okay, huwag kayong mawawala. N square is equal to, para maging equal siya, in-square natin si n, in-square natin din yung right side, which is 2k square. Therefore, 2k will become 4k square. Okay? Now, paano naging 2 times 2k? Okay, paano naging 2 times the quantity 2k square? So, in this part, we factored out 2 in our 4. Diba? 2 times 2 is 4. So, therefore, we factored out 2. Ang natira is 2k square. Therefore, what we can have in our conclusion is n square is even. Okay? So, that is our conclusion. So, we prove that n is even implies n square is also even. Now, using the contrapositive, ano ang contrapositive ni even? We conclude that n square is not even. Di ba? Yung una natin, n square is odd. Ano ang contrapositive ni odd? Even. Okay? So, we conclude that n square is even. Therefore, the contrapositive of n square is even. N square is not even. Therefore, it is odd. It implies n is not even, but it is odd, which proves the statement correct. Okay? Therefore, this statement is correct. Okay? And lastly, but definitely not the least, this is one of the most important part of our mathematical induction, proving by mathematical investigation, which is proving by mathematical induction. So this lesson is found in your pre-calculus lesson. If you want to study it further, or if you want to uh, have more examples or study more examples, you can have it in your pre-calculus book. So proving by mathematical induction, we let P of n be a statement concerning the positive integer n. Suppose that P of 1 is true and P of k is true, then P of k plus 1 is true. So we have to satisfy these three parts or three stages in proving mathematical induction. Then we can, if we satisfy that, if we prove that those three are true, then the statement P of n is true for all positive integers n. What am I trying to say? This is the outline of the proof of mathematical induction. Meaning, this will be the stages. So, in this part, we have first the verification. Verification, we prove that n is equal to 1. So, we let n is equal to 1. Palagi yan. I-prove nyo na palagi si n is equal to 1. So, you have to substitute 1 in place of n. Okay? And then, dapat mag-equal siya sa 1. Next, the second part is the induction hypothesis. We assume that the statement is true for n is equal to k. So, lahat ng lahat ng n papalitan natin ng k. And the third part is the proof. We prove that the statement is true for n is equal to k plus 1. Anong gagawin natin sa second, ma'am? Basta papalitan natin sila ng lahat ng n ng k, and then we prove na si n ay equal sa k plus 1, dapat makuha natin yung pangalawa. Okay? And then the last part is the conclusion. This is the most important part. So, let's have example number 1. I hope you are still there listening. You may get your pencil and your paper, and then you may try solving it. Okay? So, example 1, using mathematical induction, prove that 1 plus 2 plus 3 plus up to n is equal to n times n plus 1 over 2. Familiar? Familiar ba sa inyo? I hope familiar siya. Ito yung mga binuo nating formula mula dun sa pattern na nabuo natin noong session 2 dun sa pattern finding. Naalala na ba? So, if you had this one, you had the conjecture, gumawa na kayo ng conjecture, and then naghanap na kayong pattern, and then nakagawa kayo ng formula. This is now the next step, which is you have to prove that your formula is true, okay? Using the mathematical induction. So, pwede kayong mamili dun sa apat. So, pero ito yung pinaka-madalas na ginagamit, mathematical induction. That's why marami siyang example. Okay? So, our given is 1 plus 2 plus 3 plus up to n is equal to n times the quantity n plus 1 over 2 for all positive integers n. Okay? So, this is now our solution. So, first, verification. So, our verification is to verify that n is equal to 1. So, we're going to substitute 1 in place of n. So, this is our original formula. N times the quantity n plus 1 over 2 equals, so lahat ng n, papalitan natin ng 1. 1 times the quantity 1 plus 1 over 2 equals, 1 plus 1 is 2. Ito yun. And then 1 times 2 is 2 over 2. 2 over 2 is 1. Therefore, the formula is true for n plus 1. So, okay na yung first stage natin. Second stage, induction hypothesis. We let n is equal to k. Walang gagawin dito, kundi papalitan lang si n by k. Okay? So, this is our original, this is our formula after we substitute n by k. So, 1 plus 2 plus 3 up to k, pinalitan lang natin ha, wala tayong ginawa, pinalitan lang natin ng k si n equals, so this is our original, okay? Ito, i-highlight ko. I hope nakikita nyo. So, pag-compare nyo, kung tama yung ano, palitan lang natin ng k si n. So, k times the quantity k plus 1 over 2. So, binago ba natin yung format? Pinalitan lang natin si n by k. That is our induction hypothesis. Stage 2. This is now our stage 3. I hope you understand that. The proving itself. So in our proof, we show that our original formula, we replace n by k plus 1. Kailangan pala makita ninyo. Kunin ko to ha. Asan ba yung yung original? Ito. Okay, I am going to insert a text box para makita nyo kung ano yung pinoprove natin na ayun. I hope nakikita nyo siya. 1 plus 3, 2 plus 3 plus n is equal to n times the quantity n plus 1 over 2. Okay, so anong nangyari dito? So we have replace n by k plus 1 is equal to, ano pa yung susunod? N, di ba? K plus 1. Pinagkatan natin ng k plus 1 si n. And then, n na naman, times the quantity n, k plus 1 na naman ulit. Plus 1 over 2. Kita nyo? Pinalitan lang natin si n by k plus 1. Ngayon, ito niyan yung ating dapat makuha dun sa final answer natin. Para masabi natin that this statement is true for n is equal to k plus 1. Okay? I hope you understand that. Pagsasamahin natin, yung una, ito, Yung hinighlight ko dito, ito yon. Yung ginawa natin dito, the stage 2, n is equal to k times the quantity k plus 1 over 2, and this one, the highlight, and we add k plus 1 so that we can have this one. Ito yung target natin na makuha. Si k plus 1 times the quantity k plus 1 plus 1 over 2. Okay? So, we have the original formula. 1 plus 2 plus 3 plus k. Inadd natin si k plus k plus 1. Okay? Stage 2 si k. Stage 3 si k plus 1. Okay? Inadd natin. Ano si k? Ano yung stage 2? K times the quantity k plus 1 over 2. And plus k plus 1, which is in our stage 3. Okay, I hope you understand that. Burahin ko para hindi kayo malito. Okay. Now, we have to make this as a single fraction. Ibig sabihin, gagawin natin siyang isang fraction lang kasi dalawa siya, oh. Kumbaga, ito, whole number ito, fraction ito. Ngayon, para ma-add yan, di ba, gawin nating isang fraction. Paano? So, ganito siya. Equals, ang denominator natin is 2, and then 2 divided by 2 is 1 times k times the quantity k plus 1. Of course, we will have k plus 1. Ang hirap pagsulat. Okay. K times the quantity k plus 1. Okay? Plus 2 divided by, may denominator to na 1, 2 divided by 1 is equal to 2 times k plus 1 equals 2 times k plus 1. So, as you can see, ito nakuha natin. Okay? So, ganun siya nakuha. Next. So, anong ginawa dito? Remember, common monomial factor. So, common monomial factor natin dito ay k plus 1 and k plus 1. We factored out k plus 1. So, I hope you understand that. Ang galing ko yung mga kulay. Okay. So, our common monomial factor here is k plus 1. Eto. Okay? So, i-factor out natin siya. So, magiging isa na lang siya. Gaya ng ginawa natin sa 2 kanina. So, k plus 1, ano natira? Siyempre, si k at si 2. So, gagawin natin silang isang binomial. Si k at si 2 na lang. Eto siya. Okay, I hope you understand that. Over 2. Now, i-factor out natin si 1 or i-factor natin si 2 para makuha natin yung original. Remember, we are trying to get this part, the original formula na ginawa natin so that we can show that n is equal to k plus 1. Okay? Now, we factor out 1 plus 1. So, ito si k plus 1. Okay? Ito yon, k plus 1. Sinulat lang natin. And then, factor out 2. We factor 2. Naging k plus 1. Okay? Walang nangyari dito. Pareho lang yan. Plus 1. Kung ipa-plus mo to, pinakita lang natin nandun si k plus 1. 1 plus 1 equals 2. Pareho lang yan. K plus 2, K plus 1, pareho lang yan. Over 2. Hindi ba to? Itong buong ito. Ito yon. So, Nakuha natin. Therefore, the statement is true for n is equal to k plus 1. Okay, did you understand that? I hope naintindihan nyo. Next, for our conclusion, uh, since we have proven the conditions required by the principle of mathematical induction, therefore the formula is true for all positive integers n. So that is our conclusion. Okay? Do you have any questions? Wala. Okay. I hope that silence means I understand, ma'am. Or we understand. Next, we have this example number 2. Using mathematical induction, prove that 1 square plus 2 square plus 3 square plus n square is equal to n times the quantity n plus 1 times the quantity 2n plus 1 over 6. So for all positive integers n. So that is our original formula. So we are trying to prove using mathematical induction. Okay, so I'm going to insert a text box first para makita nyo na we're trying to prove this one. Okay, so I hope you can see it. Using verification, we let n is equal to 1. So, ito yung original natin. So, sinubstitute lang natin yung 1 sa n. So, 1 times 1 plus 1 times 2 times 1 plus 1. So, over 6. So, 1 plus 1 is 2. 2 times 1 is 2 plus 1 is 3. 1 times 2 times 3 is 6 over 6 equals 1. Therefore, the formula is true for n is equal to 1. Okay? Remember mathematical induction, we are trying to prove 3 stages. N is equal to 1, n is equal to k, and n is equal to k plus 1. Okay? Now, in number 2, stage 2, induction hypothesis, n is equal to k. So, we just let, kasi gagamitin natin to later, n is equal to k. So, this is our original formula. Hope you can see that. And then, we let n is equal to k. So, 1 square plus 2 square plus 3 square is equal to k square is equal to k times the quantity k plus 1 times the quantity 2k plus 1 over 6. So, we will reserve that later. Now, in our stage 3 proof, we let n is equal to k plus 1. So, we add k square. Ito yon plus k plus 1, k plus 1. Bakit may square si k plus 1? Kasi nga n square yung ating n. Okay? So, we let, okay. So, our formula will be k plus 1 times k plus 2 times 2 times k plus 1 plus 1 over 6. Ma'am, anong ginawa mo? Paano nangyari yon? Okay. 'Di ba k plus 1 yung ating nire-replace in place of n. So, this is our original formula. Ang ingay ng pusa ko, sana hindi niyo naririnig. Shh! Okay, so, this is our n square. Okay, n square, papalitan natin siya ng, idadagdag natin dun sa stage 2. Kaya siya naging k. N is equal to k. Okay? Tapos, dito sa stage 3, dinagdag pa natin si k plus 1. Kaya siya naging k plus 1 square. Kasi n square ito. I hope you get that. Next, palitan lahat ng n by k plus 1. N ito. So, we have k plus 1. Tapos, n plus 1 ito. So, hindi na pinakita dito na pinlas. K plus 1 plus 1. So, k plus 1 plus 1 plus 1 is 2. Kaya siya naging k plus 2. Next, 2n. 2 times the quantity, palitan si n ng k plus 1, naging 2 times the quantity, 2k plus 1 plus 1. So, evaluating this, we have k plus 1 times k plus 2 times 2k plus 3. Paano nangyari yon? 2 times k is 2k. Ito yon. 2 times 1 is 2. Plus 1 is 3. Kaya siya naging 2k plus 3. So, this now is what we are trying to prove. So, ito yung kinukuha natin. The quantity k plus 1 times the quantity k plus 2 times the quantity 2k plus 3 over 6. Now, using our formula, na sinubstitute natin si k at si k plus 1, yung ating second stage, which is ito, k times the quantity k plus 1, yung nakuha natin sa stage 2, times 2k plus 1, isa-substitute natin siya dito. So, ito siya. Plus k plus 1 squared. Ito yon. Okay? So, I hope na nagigets nyo. Next, gawin natin isang ano ulit. Gawin natin isang fraction. Equals, si 6 ang ating denominator. And then, of course, 6 divided by 6 is 1. We get this one. K times the quantity k plus 1 times 2k plus 1. Okay, 6 divided by 1. May 1 na denominator to. Of course, 6 times k plus 1 square is equal to 6 times the quantity k plus 1 square. So, kaya siya naging ganon. Okay? So, ito yon. Okay? Hope you understand that. Okay? Ito yung kinalabasan niya. Next, what we're going to do here is, we're going to factor out k plus 1. Tanggalin natin para makita nyo yung i-factor out natin. Okay, so let's factor out k plus 1. Ito yon. K plus 1 sa isang term at k plus 1 sa second term. Okay, so ito yung k plus 1 na finactor out natin. So ano natira sa k plus 1, sa first term? Si k at si 2k plus 1. Ito siya. At sa second term ay 6. Kung napapansin nyo, may square dito. Kaya may k plus 1 pa tayo dito. Okay? Next, distribute k. K times 2k. 2k square. K times 1. Okay, siguro gawin natin dito. So, k plus 1. Hindi siya pinalitaw eh. Times the quantity k 2k plus 1 plus 6k plus 1. Ang hirap magsulat. Over 6. So, anong ginawa dito? Equals. So, write natin si k plus 1. And then, k times 2k is 2k square. K times 1 is plus k. And then 6 times k is 6k. 6 times 1 is 6. So, I hope you understand this one. Kaya siya naging ganito. Okay, kaya siya naging ganito. Okay, now, factoring, ano ang tawag dito? Factoring trinomial. Hindi siya perfect square, pero we can, factorable siya. Okay? So, factoring 2k square plus 7k plus 6, we will have, so we will write k plus 1, the factors of 2k square plus 7 plus 6 is k plus 2 times the quantity 2k plus 3 over 6. Hindi ba ito yon? Diba? Therefore, the statement is true for n is equal to k plus 1. And for our conclusion, therefore, by the principle of mathematical induction, 1 square plus 2 square plus 3 square plus n square is equal to n times the quantity n plus 1 times the quantity 2n plus 1 over 6 for all positive integers n. And lastly, our example number 3. So we have to prove that 4n or 4 raised to n minus 1 is divisible by 3. So, kung napapansin nyo, pwede rin yung mga divisibility rules sa mathematical induction. So, this is how we prove that. So, we are going to prove that 4 raised to n minus 1 is divisible by 3. 4n is greater than or equal to 1. Ibig sabihin, pwedeng 1. Ano yung mga greater than 1? 2, 3, 4, pataas. Okay? So, pwedeng lahat ng mataas kay 1, simula kay 1, pataas, pwede mong ilagay as verification in order to verify if n in our stage 1. So, nakikita nyo, n is equal to 1, 4 raised to 1, minus 1, we have 4 minus 1 is 3. Does it divide 3? Ibig sabihin, divisible by 3 ba si 3? Oo, 3 divided by 3 is 1. Wala siyang remainder. Pag sinabing divisible, pag dinivide mo yung number dun sa 3 or dun sa any number na given, wala siyang ang tawag doon, remainder, therefore it is divisible. So, 3 is divisible by 3. Next, let's verify n is equal to 2. So, 4 raised to 4 square minus 1 is equal to 16 minus 1 equals 15. So, is 15 divisible by 3? 15 divided by 3 is 5. Therefore, it is divisible. So, check yung ating stage 1. Next, induction hypothesis. We let k, n is equal to k. Assume that the statement is true for n is equal to k. Okay, take note of this ha. So, pinalitan na natin. 3, dapat ito yung ating ano, 3 divides 4k, 4 raised to k minus 1. We let 4 raised to k minus 1 equals 3m, where m is an element of an integer. Okay? So, tatandaan yan kasi gagamitin natin dito. Now, in proving, we let the statement, we have to prove that the statement is true for n is equal to k plus 1. So, pinalitan natin ng k plus 1 si n. So, we have 3 divides 4 raised to k plus 1 minus 1. Next, anong ginawa natin dito? We, okay, we substitute our k plus 1, okay, this is 1, in our original format or formula. And then we add 3. Okay? Next, palitan natin dito, kung natatandaan nyo, si 4ki equal kay 3m. So, pinalitan natin si 4 raised to k minus 1 by 3m. And then, we have this common monomial factor which is 3. We factor out 3. Ito siya. And what remains is 4m plus 1. 3 times the quantity 4m plus 1. And we let q be equal to 4m plus 1. So, we will have, palitan natin si 4m plus 1 by q. So, we have 3q. So, therefore, napakita natin that 3 divided by 3 divides 3q, therefore 4 raised to k minus 1 is divisible by 3. So that is our stage 3. Next, for our conclusion, since the statement is true for n minus 1 and also true for n is equal to k plus 1, whenever n is equal to k, then the given statement is true for all positive integers n. And now for your capstone task number 2, since it is already 9:56, yung mga numbers na pinabunot ko sa inyo, colors rather, ito yung mga inyong mga sasagutan. So we have the conjecture 1, conjecture 2, conjecture 3, conjecture 4, and conjecture 5. So that's the end of our session today. Do you have any question?